writing sums like this 1 plus 2 plus 3 plus dot 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 plus 100, this gets a little clumsy, and for this we have something called sigma notation. The sigma is actually a letter of the Greek alphabet. It is pronounced sa like our S, and this is the uppercase sigma. There is also a lowercase sigma, small sigma, which is written like this, but here we will only be using uppercase sigma. So, this sum here 1 plus 2 plus 3 up to 100, this can be written as sum I goes from 1 to 100 of I. What this means is that I will start with I equal to 1. Let me start with a slightly smaller example. So, what is the meaning of I goes from 1 to 3 I? This means I will start with I equals 1, then I will be 2, and then I will be 3. This is a bit like a loop in computer programming. In Python, for example, you would write this as sum I for I in. Well, in Python there is something strange. We usually use range for looping, and range starts with 0. So, I would say 1 to 4, it will stop at 3. For those of you who know Python, otherwise ignore this. I could do variants of this. Suppose I wanted to add I goes 3 plus 4 plus 5 plus 6. So, I want 3 plus 4 plus 5 plus 6. So, what would I say? I would say I goes from 3 to 6 I. I could also say I goes from 1 to 4 of I plus 2. See, because here if I put I equals 1, then this is 1 plus 2, then I put I equals 2, that is 2 plus 2 plus 3 plus 2 plus 4 plus 2. This term here is I equals 1, this term here is I equals 2, this is I equals 3, this is I equals 4. Okay, so I can vary the range of the index, and I can also put different expressions in front of the sigma. So, what we proved earlier today with Viswanath was the formula 1 plus 2 plus 3 plus dot 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 all the way up to n is n into n plus 1 divided by 2. I can write this as summation I goes from 1 to n, I is equal to n into n plus 1 by 2. Another formula we proved was 1 plus 3 plus dot 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 goes up to 2n minus 1, this is equal to n squared. So, this I can write as I goes from 1 to n. So, I want when I equals 1 I want 1, when I equals 2 I want 3, when I equals 3 I want 5 and so on. So, what I need to write here is 2I minus 1 is equal to n squared. 2I minus 1 is the ith odd number, and so what I am saying is we are adding the first n odd numbers and then we get n squared. We can also have double sums. So, for example, here is something that is scary looking, but we will sort through it. So, I goes from 1 to 3, and then I will do j. I have two counters, j goes from 1 to 3, I times j. So, what does this mean? So, what we can do is we can think of it as a sum over the index j, j goes from 1 to 3 of something which depends on j, and the thing which depends on j is what I have drawn inside the parentheses. So, I goes from 1 to 3 ij. So, here first I will be taking j equals 1. So, I will be taking first I goes from 1 to 3 I into 1, then I will be taking I goes from 1 to 3 I into 2, and then I will be taking I goes from 1 to 3 I into 3, and that becomes so this 1, all the terms here are multiplied by 1, I can just take the 1 out as a common factor. Well, 1 of course does not do much when you multiply by 1, but in the next term this will matter. So, this 2 I can pull out as a common factor, I can bring it up front. 2 into I goes from 1 to 3, I plus 3 into I goes from 1 to 3. So, that is 1 into 6 plus 2 into 6 plus 3 into 6, which is again taking the factor 6 out common, that is 1 plus 2 plus 3 into 6, which is 36.